In this video, we're going to investigate the idea of square roots. So here are the directions. Determine whether the given figures can be rearranged into squares with whole number side lengths. If so, determine the square root of the number. If not, determine what two perfect squares the number lies between. Okay. So here we're given 12 square units. Okay. And if we wanted to, you could think of, maybe if this was made of Play-Doh, you could think of moving this around, moving the area, and making a square out of it. But what we're most interested in right now is it a perfect square? So a perfect square is when we have whole number side lengths. So here's what we're going to do. We know we have 12 square units, so we're going to use this spiraling method. I'm going to start by labeling one square 1. Okay. Now notice this 1 is a perfect square, okay, because it has a side length of 1 for each side. Okay. But we have 12 square units, so we're going to keep going and we're going to spiral out. 2, we have 3, we have 4. Okay, we need to go all the way up to 12, but notice that 4 is a perfect square as well, because if you have 4 squares, it's a square that has whole number length sides of 2. So let's keep going. 5, 6, 7, 8, 9. Okay, we're not there yet. We're not up to 12, but notice 9 is a perfect square. Now we have a 3 by 3 square. I'm deciding I want to write these here. So we have 1 squared was 1, 2 squared was 4, and 3 squared was 9. Okay, now we're going to keep going till we get to 12, and we have 10, 11, 12. Okay, so notice we do not have a perfect square. Let's shade this in. Let's kind of just turn the figure around, but we got to see all the perfect squares in between. So this was our figure. Okay, and we know that it's larger than 3 squared. And if we wanted to, we could keep going to see what the next square would be. 15, oops, I skipped 13. 13, 14, 15, 16. And if we went to 16, that would be 4 squared. Okay. So our first answer is 12 a perfect square, and our answer is no. We could not use, we checked 1, 2, 3, 4, and we could not use any of those numbers to make a square using 12 square units, none of those whole numbers. Okay. If 12 is a perfect square, what does square root of 12 equal? Okay, so it's not, so I'll just put not a perfect square. And the next question, this is the one that applies to us. If 12 is not a perfect square, what two whole numbers does square root of 12 lie between? Well, notice 12 lies between 9 and 16. So that means the square root of 12, which is saying what number multiplied by itself is 12. It's not a whole number, but it is between 3 multiplied by itself and 4 multiplied by itself. So the square root of 12 is between 3 and 4. Okay? There is a number that has the property when you multiply it by itself, you get 12. Okay? It's going to be what we call an irrational number like pi, and even though it doesn't ask us to here, I'm just going to show you on the calculator. Okay, there's a square root button here somewhere. So I'm going to hit 12, and that's my square root button. So this is a number, if you multiply it by itself, the decimal actually goes on forever, just like pi. There's no patterns, it never ends. If you multiply this number by itself, you will get 12. Notice it's bigger than 3, and it's smaller than 4, because it was 12 is between 9 and 16. Let's look at the next one. Now we're given 36 square units, and we're going to use the spiral method to see if 36 is a perfect square, if we can rearrange these as a perfect square. So let's start right here. 1, 2, 3, 4. Just going to spiral around. 5, 6, 7, 8, 9. 9's a perfect square. Keep going. 10, 11, 12, 13, 14, 15, 16. 16's a perfect square, but we have to keep going. Up to 21, 22, 23, 24, 25. Notice 25 is 5 by 5, but we have to keep going. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, and here's 36. Now let's shade this so we can get a better picture of it. So this is 36 square units. Certainly looks like a square. Okay. And to double check, let's count the side lengths. So this is 1, 2, 3, 4, 5, 6. This is 6 units. And this way we also have 1, 2, 3, 4, 5, 6. So this is 6 units. So we have 6 squared equals 36. So that means, is 36 a perfect square? Yes, it is. So even though this represented 36 square units, we could also use the spiral method to see that we could also rearrange those into a perfect square. If 36 is a perfect square, what does square root of 36 equal? So the square root of 36, again, means what number multiplied by itself equals 36. Okay, and we found that there is such a number, and that number is 6. 6 squared means 6 times 6. So if I multiply 6 by itself, I get 36. Therefore, the square root of 36 equals 6. Let's look at the next question. If you added one more square unit, you would have 37 square units. Is 37 a perfect square? How do you know? Okay, so I want you to imagine that, and then we'll actually do it. Okay, is it possible if you add one more square unit, is that going to make a perfect square? Well, notice if I add one more in my spiral, it's no longer a perfect square. There's no way we were going to go all the way around and make a perfect square. Okay, so the answer is no. 37 square units isn't a perfect square. Based on our diagram. Okay, and notice neither is 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. We'd have to go all the way to 49, which would be 7 by 7 to get to our next perfect square. So then it asks, what two whole numbers does the square root of 37 lie between? Well, we saw that 37 is between 36 and 49. Okay, it's between these two numbers. So that means its square root is between 6 and 7. So square root of 37 is between 6 and 7. And now we're just going to practice finding some square roots on the calculator. Typically this is how we'll find a square root. You should be familiar with perfect squares. It's not the end of the world if you forget one, because you can always find it on your calculator or use multiplication. So the directions read, find the square root of each of the following, round to 2 decimal places if needed, indicate those that are perfect squares, and explain why. So we have square root of 81. So remember, this means what number do I multiply by itself to get 81? And you may know that number. Your calculator is probably fancier than this one, and it will have a square root button. This is mine. On your calculator, you probably have to hit the square root button, then enter the number. On this really old free version, I hit the square root button afterwards. Okay, so the square root of 81 is 9. And this is a perfect square because 9 squared equals 81. So it's a perfect square when we have a whole number answer. Okay. Square root of 20. Well, I know 20 is between 16 and 25. Those are perfect squares. So this is not going to be 1, but let's see what it is. So we will round this to 2 decimal places. It's about 4.47. Okay, and it's not a perfect square. Square root of 9, well, we saw already what number times itself equals 9. And we know that that's 3. So this equals 3. And it is a perfect square because 3 squared equals 9. And now square root of 60. So when I look at that, I say it's between 49, which is 7 squared, and 64, which is 8 squared. So it's not going to be a perfect square. It's going to be between 7 and 8. And let's see what that value is to 2 decimal places. It is about 7.75. So that's our approximation, 7.75.